have astronomers discovered the first generation of stars. With the help of an intervening galaxy cluster, astronomers have found what might be the first generation of stars, but the jury's still out. The galaxy cluster MATS 0416, imaged by the Hubble and James Webb Space Telescopes, has magnified the light from distant sources in the baclogram round. One of those sources is an early cluster that might host stars of the first generation. Image Nise Ise Cic Jose Diego Ifka, Jordan da Silva, Uo, Anton Coitmore Stacey, Jake Summers SO, Roger Weinkorst SO, Holding Yan, University of Missouri. Image processing Joseph de Pasquale Society. Using the James Webb Space Telescope, astronomers might have spotted some of the first stars to form after the Big Bang. Just like humans, stars exist in multiple generations. This lineage comes down to the amount of elements heavier than hydrogen and helium they contain. Immediately after the Big Bang, hydrogen and helium were the only two elements to exist in any sizable quantity. So when the first stars formed, what astronomers refer to as population E stars, they were made of only hydrogen and helium. When those massive stars died in supernovae, the explosions forged the heavier elements that became part of the next generation of stars, what astronomers term population stars. Then, when those stars perished, they enriched population I stars such as the Sun with still more heavy elements. Of all of these, population Ye stars are particularly challenging to observe. Not only did they exist a long time ago, meaning they are incredibly far away, they also lived particularly short lives. Now, a team led by Elie Wiesel, the University of Toledo, has reported in the Astrophysical Journal Letters the discovery of potential population E stars. The cluster they reside in, known as LAP-1, is possibly the core of a tiny, early galaxy. The universe was just 800 million years old when its light set off for Earth. The ancient cluster is visible in part because a foreground galaxy cluster, MAX I0416, magnified the baclogram round star's light by a factor of 100. Finding this early population of stars is important for more than understanding star formation. They teach us about the earliest stages of galaxy formation and evolution, says Wiesel. They may also constrain the particle nature of dark matter, since some proposed dark matter models impact where population E stars first form. There have been claims of population E stars before, but none have satisfied all three of the main theoretical predictions for how and where these stars should appear. In the standard model of cosmology, population E stars are expected to form in very small dark matter structures that serve as building blocks for larger galaxies, Wiesel says. LAP-1 ticks that box. Also, the cluster's spectrum is consistent with a total mass of about 1,000 suns. This is about the total mass of population any clusters we see in numerical simulations, he adds. The third clue lies in the types of stars the cluster seems to contain. There he predicts that population Ye systems should be dominated by massive, short-lived stars, since hydrogen and helium gas can't cool as easily, making it harder to fragment those early balls of gas into smaller, longer-lasting stars. The spectrum of LAP-1 matches the prediction, indicating a population weighted heavily toward the high-mass end. Harley Katz, University of Oxford, who was not involved in the research, agrees that these observations may be consistent with the trio of predictions regarding population E stars. Unfortunately, this does not necessarily mean this is a poppy system, he says. Nevertheless, it is so far the closest we have come. One key issue is that LAP-1's spectrum shows weak emission lines that indicate the presence of heavier elements, known as metals, such as oxygen and possibly carbon. The fact that we see any metal emission is worrying, as poppy stars, by definition, form from metal-free gas, Katz says. These signals could mean the system's gas has been lightly enriched by the deaths of an earlier generation of massive stars. Wiesel concedes that we don't know for sure. Deeper observations, improved simulations, and additional similar sources would help to build confidence. He says